Next, domain. I suppose the domain is a real number because never is zero. The denominator is a fraction. Entonces es a real number. The range is very complicated to find. I can predict something, but I'm not sure 100% for the range. I suppose que es a fraction. I can see the denominator always is bigger than the denominator. So never is greater than 1. It's a fraction. This is in between -1 and +1 because with the x is negative, it's a negative fraction. But I want to verification after that. Question mark. Okay, now y-intercept. Evaluate 0. It's obvious que 0, 0, 0 again is x-intercept and y-intercept both. X-intercept, we have no more because h of x equals 0 is equivalent to say x is 0. Numerator 0. 0, 0 is only the x-intercept and y-intercept both. Symmetry. Symmetry is replace for negative x. It's negative x over square root negative x squared plus 1. It's obvious that this part stays the same because the exponent is even number, but it's not. Entonces this is a classical odd function. Okay, now the asymptote. Es obvio que no vericast. Okay, no, never is 0 that part. Horizontal, yes, it's the aim behavior, but be careful because it's this radical function. Entonces no necessarily is the same aim behavior to the right or to the left. So I need to compute the x when I approach it to positive infinity of x over square root x squared plus 1, and also separately limit it when the x approaches to minus infinity of the x over square root x squared plus 1. Entonces this is applied dominant, this is approximately x over square root x squared is actual value, and this is x actual value is x because we are working with the positive numbers. So the actual value is equal x. The answer is 1. So yes, we have horizontal asymptote at y equal. Let's see a negative infinity what happens. Well, this is saying approximately x over square root x squared. Is x over actual value x. But in this case, actual value is no x, sino es minus x. The answer is -1. Wow, it's a typical example. Okay, we have two different horizontal asymptotes and the direction is -1. Now the calculus part. Okay, derivatives. H prime of x is equal Gaussian rule. But in the denominator we have this square que es obvio que square and square root together cancel out each other. X squared plus 1. So now you derive the numerator que es 1 times square root x squared plus 1 minus the, well, this is the square root is you know, is 1/2 because you can understand that this is square root x squared plus 1 is equal x squared plus 1 raised to the 1/2 power. Entonces es x squared plus 1 raised to the -1/2 time the derivative of the expression inside is 2x. And don't forget the other x of the numerator, no? It's x squared. Is it cancel? These two is cancel. And you can write that part like a square root x squared plus 1 minus x squared, yeah, over square root x squared plus 1. Okay, cool. Let me copy only the numerator part because I want to condensing and LCD. Entonces this time this is x squared plus 1 without square and square root minus x squared. Wow, that's part is cancelled to stay alive. Just one over. And don't forget that part. Now it's a moment to copy. No equals, imply x squared plus 1 times square root x squared plus 1. Okay, cool. This is the expression that represents the first derivative. This is h prime of x. If you want to find critical value, you enforce it to be 0, but this is no solution. It's obvious that no solution because numerator is 1. So no critical value. No critical value. See, no critical value. We have never max min local. No. For me it's clear que this expression is not 0, but it's always positive. Entonces that means que the function h of x is always increasing. Function. Always. Everywhere. Let's go to the second derivative. Okay, entonces now I try to manipulate algebraically here to make it easy. Okay, this expression is 1 over x squared plus 1 square root x squared plus 1. And this is together, it's the same, no? It's a 1 and 1/2 is 3/2. Entonces it's 1 over x squared plus 1 raised to the 3/2, que is equivalent to say x squared plus 1 raised to the minus 3/2. Okay, this is the equivalent of the first derivative, but it's easier to compute the second derivative. Let me try. Second derivative is negative 3 over 2 parentheses x squared plus 1 and negative 3/2 minus 1 is negative 5 over 2 times 2x. One more time happen because these two is cancelled. Let me put in elegant way. This is minus 3x over x squared plus 1 raised to the positive 5 over 2. Okay, and you see it always is negative. Well, no, always, no, depende, no, see x, o sea, x equals 0, you enforce it to be 0. I'm going to find a potential inflection point. And so because the solution of this is x equals 0. Okay. Now x equals 0. There's a potential inflection point. I want to verification using the second derivative test. This is x0. Suppose hypothetically, when the x is less than 0, here x less than 0, it's obvious that the answer is positive because we have double negative, no? And the curve is concave up. And when it's negative, when it's positive, sorry. Entonces positive and negative is negative. Entonces cuando x is positive, it's concave down. It's 0. Okay, entonces yes, it is a inflection point, that by the way is a point 0, 0. Okay, let's see now the Desmos graphic. Okay, Desmos now. Do you see? I copy the function. I determined that we have two horizontal acetone and one and -1, also infinity, -infinity. And the important information is the second derivative. This second derivative of the negative is that part is concave down, and the second derivative of the positive is concave up. Okay, super. Very well.